Before we begin talking about angles formed by tangents and secants, let's explore these very important vocabulary words. One, tangents. A line or line segment that skims by a circle, only touching it at one point. So if I were to draw a tangent line to this circle, number one, the line could start really anywhere and it really could end anywhere. However, it would only touch the circle at one point. Now, I could also go back to that very same starting point and draw only one other tangent. Now, you can see the tangent could be extended or it could actually even end on the circle. However, if it's a tangent line, it's only going to touch the circle at exactly one point. Now, something that's very important to remember, which is written down below, is that if you happen to draw or have a radius drawn to a point of tangency, they will always be perpendicular. So one thing that would always be true, therefore, is that if we went from the center of the circle to, say, that point of tangency, that would be creating a right angle with the tangent, right? Because radii are always perpendicular to the point of tangency. Okay, let's go to number two, a secant. A secant is a line or a line segment that passes through a circle intersecting it at 2 points. So if I were to draw a secant, it would enter and leave the circle, thereby being a secant. And often when we see secants, they kind of stop at the end of the circle. And of course, you could draw many secants from any one particular point. See how they enter and exit, intersecting the circle at 2 points. So a tangent only touches the circle once, and a secant will touch the circle twice. Okay. Exterior angles formed by tangents and or secants lead to three possible scenarios that we're going to be dealing with. We can have two tangent scenario, we can have a one tangent and one secant scenario, or we can have a two secant scenario. So let's look at the first one, the two secants. Well, the angles that we're going to be paying the most attention to are these angles that are formed outside the circle. So here at point P, I'm going to put a little X there because the angle that we're really interested in is this angle right here. It could be referred to as angle P, but I'll put a little X there. Now, if we have two tangents from one point to one circle, they're only going to touch that circle twice, here at point A and here at point B. Now, one thing that's important to note is that two tangents going from one point to one circle will divide the circle into only two arcs. Here, you could see that we're going to have minor arc AB and we're also going to have major arc A. I put that little point there so we can understand that we can go the other direction, ARB. So if we were looking at, this, the minor arc from A to B, you could see how that arc is inside our angle still. And if we were going to look at the major arc, it would go all the way around the other direction back to B, dividing the whole entire circle into two arcs. Well, let's take a look at the second case scenario with one tangent and one secant. Well, now we have actually three different points of intersection. Since CM is a tangent, it's It's only going to touch once. And since MDE is a secant, it's going to touch one and twice. Now you could see that a one tangent, one secant scenario will divide the circle into three arcs. We have arc CD, which we'll refer to as the minor arc. You'll see why in a second. We also have arc DE, which you'll see in a moment is also important to understand. And then we have arc CE. We're going to refer to that as the major arc, right? We're going to call this the minor, and we're going to call this the major. I'm going to show you why. The two arcs that we're always going to be interested in are the minor and the major arc when we're referring to this exterior angle. So if we were just to look at this angle getting, wider and wider, right? The first place that it touches the circle is at C and D. So this is the minor arc because it's the smaller arc closest to the angle, still inside the angle. Now we also have this other arc right here, arc DE, which might be important for something else, but that arc is not inside our angle. So we're not going to use it in our future theorem that you're going to see in just a moment. However, this other arc out here, arc CE, is still inside our angle, and it's the larger one. So we're going to refer to that as our major arc. So a little bit trickier here in the one tangent, one secant scenario in that it's dividing the circle into three arcs. But the two important arcs are the two arcs that are inside my angle. And the minor one, the smaller one would be CD, and the larger one would be CE. And then finally, we have the two secant scenario. Here's where we have 1, 2, 3, 4 points of intersection leading to a circle that's divided into four arcs, right? If I'm writing down all the different arcs here, we have arc VY, we have arc YZ, we have arc WZ, and we have arc WV. Well, the two arcs out of those four that are the most important for us, if we're going to be getting involved in this angle out here, angle T, are going to be our minor and our major arcs, which the one that's inside the angle, closer to the angle, is going to be our minor, and the one still inside our angle on the outside far part of the circle is going to be our major. So in this particular case, our minor arc, we're going to refer to that as arc VY, and our major arc is going to be the WZ arc, because those two arcs are inside my angle all the way out here. Okay, now before we get to the theorem and how to find that angle, let's just quickly review what we've already learned. We started with central angles, the angles formed by two radii with the vertex at the center, and we learned that whatever that angle is, the intercepted arc will be exactly the same because we have a 1-to-1 ratio with central angles to their intercepted arcs. And then we went on to inscribed angles, and we learned, well, that's formed by two chords and the vertex is on the circle. And here we have a 1-to-2 ratio of the angle to the intercepted arc. So this would be 2x. And then finally, we got to the intersecting chord angles, right? This angle right here. And here for the first time, I'm referring to those two arcs with lowercase letters. To refer to the entire arc with a lowercase letter is acceptable. And here, what we did was learned that if we take arc A and add it to arc B and divide it by 2, we would find that angle. One's too big, one's too small. To find the number right in the middle, we're going to add them and divide by 2, and that would give us that angle. And of course, another way to look at that was 1/2 of arc A plus arc B, right? Two ways to do the same would be equal to that angle. Right, so that's what we've done thus far. So now we get to the final stage here. Angles formed outside the circle by intersection of two tangents, two secants, or a tangent and a secant. Now, one good thing about all of these three scenarios is that they all really have the same theorem. And it's not so different from the scenario with the intersecting chords, where we had to take two important arcs and add them and cut it in half. Here, we're going to take the two very, very important arcs and subtract them and then divide it in half. You could see inside the box there, the angle formed outside is equal to 1/2, not the sum, but the difference of the intercepted arcs. So let's see what that means here. Well, this particular situation that they're showing us here is one where we have an exterior angle formed. We can call it, say, angle B or angle ABC. I'll put a little X there just to, I don't want to do that. Let's do that with a black pen. Put a little X here, right? That angle right there. Now, if you follow a tangent, it's only going to touch the circle once here, and it's only going to touch the circle once here because those are tangents. Well, we still have the concept of our minor and our major arc. The arc that goes back in towards the angle, but still inside the angle, is our minor arc. And the arc that goes from those same 2 points out in the other direction, arc ADC, that would be our major arc. Now, two tangents only divide the circle into two arcs, so pretty simply, we're going to take the major arc, which is 240 degrees, and we're going to subtract it from our minor arc, which is 120 degrees, right? So we end up with 240 minus 120 divided by 2. And 240 minus 120 is 120 divided by 2. And of course, that's going to be equal to 60 degrees. And how they did it right here is just 1/2 of the difference. 1/2 of 120 equals 60 degrees. All right, let's take a look at some problems. Here's a pretty basic problem. Question 35 states, in the accompanying diagram, tangent PA and secant PBC are drawn to circle O from point P. Well, as you could see that since PA is a tangent, it's only hitting at one point, and since PBC is a secant, it enters the circle and it kind of exits the circle here, dividing the circle into 3 different arcs. However, if you draw that arc right there, arc AB, that's what we're going to refer to as our minor arc here. And our major arc is going to be an arc that's still inside the circle, but on the opposite side, the far part of the circle. So quite simply here, we're going to take our larger major arc of 80 degrees. We're going to subtract it by 60 degrees and divide by 2. Right? It's almost like the intersecting chord theorem where you add them and divide by 2, but now we're going to subtract them and divide by 2. 80 minus 60 is 20 divided by 2, and that's going to be equal to 10 degrees. So find the measure of angle P. The measure of angle P would be equal to 10 degrees. Now, here's a slightly more complicated problem, but not that complicated. Here in the accompanying diagram, tangent PA and secant PBC are drawn to circle O. So in this particular case, we see that we have a tangent, PA, which means it's only going to touch at one point. And then you have a secant, which means it's going to touch at 1, 2 points, right? You can see the circle is divided into 3 arcs. And here's one of those problems where they tell us that something is twice something else, right? So I like to look at the smaller of the two. It says if the measure of arc ADC is twice the measure of arc AB, I like to always go to the end of that sentence. And since I don't have any x here, I'm going to represent that arc with x degrees. And of course, we represent things that are twice a particular thing. Twice x would be, that means that this whole arc, right, this whole major arc here is going to be 2x. Well, I know the theorem is the major arc minus the minor arc divided by 2 should be equal to the angle. Well, let's set that up. So we have our larger arc minus our smaller arc divided by 2 should be equal to the angle, which in this case is 50 degrees. Well, here I could simplify my 2x minus x. 2x minus 1x is going to be x over 2 is equal to 50. Now there's a number of ways we could solve this. Cross multiplication is what we've been doing a lot lately. So x times 1 is x, and 50 times 2 will be 100. So here the question is, find the measure of arc AB. Well, I represented arc AB with x, which means I could then say that the measure of arc AB is also equal to 100 degrees. And we can even go in here and check this and make sure that it's true. So if this is 100 degrees, that means this is going to be 2 times 100, which will be 200. So this makes sense because 200 minus 100 is 100. Cut that in half, and that's equal to 50, right? Works out. Question number 41. Here's a problem with 2 secants. Sometimes a little trickier just because there's a lot of arcs here. Furthermore, it says secants PR and PS are drawn to circle O from P in the figure below. You also might notice that one of those secants cut through the center of the circle, right? That's something important to remember as well. So here we go. If the measure of arc TQ is 20 degrees, so I'm going to come right here, be careful, I'm just going to put it right there, 20. I'm going to put it right on the circle, so I don't want it to get confused with the angle P. And the measure of arc TS is 90 degrees. I'll put it on 90 right here. Find the measure of angle P. Now, there's no x's in this problem, so I might as well just put an x out here in that angle, because that's really what we're looking for, angle P. Now, the important thing to remember in this problem is that the 2 arcs that are always going to be important are going to be our minor arc, which is TQ, because that's inside my angle, but also the major arc, which is where those 2 secants hit the far part of the circle. It's this arc right here. So we have to figure out what that is. Well, it's important that we can see that P, Q, O, R is cutting through the center of the circle, which means that this secant is also creating a diameter, which is also creating a semicircle, which means that arc QR down here is half of a circle, which means it must be 180 degrees. But it also means that the arc up above here, say from Q to T to S to R, is also a semicircle and will also equal 180 degrees. So to figure out that missing arc that we need, I'm going to take my 90 degrees and my 20 degrees and add it together. That's going to give me 110 degrees. And then I'm going to subtract it from 180 and get 70 degrees. Because all of these arcs here, arc QT, TS, and SR, have to add up to 180 because it's a semicircle. So now I can go back and put arc SR here of 70 degrees. And now we're ready to begin this problem. Now we could say that our major arc of 70 degrees minus the minor arc of 20 degrees divided by 2 will be equal to our angle here. I'll call that x since I put the x there. 70 minus 20 is 50 degrees divided by 2 is equal to our angle, and then we finally get 25 is equal to our x. If this is a short answer, as it is, I'm going to write the measure of angle P is equal to 25 degrees. And here, I think we have, wait, how many do I have left? Let's see. I think this is the last one. There might be one more after it. Number 36. In the diagram below, secant segments PR and PT intersect at P. If the measure of angle P is 42 degrees, okay, here they're giving me the angle, so I'm just going to put it in there, 42 degrees. And the measure of arc RT out here is 148 degrees. What is the measure of arc QS? Since there's no x in this problem, I'm going to put a little x there to represent that. Okay, so this is kind of like a backwards problem, but I'm just going to stick to my theorem here that the major arc, right? We have the major arc, I'm going to write it out, minus the minor arc, divided in half will always be equal to that exterior angle, right? That's the idea here. So here my major arc is the 148 degrees. The minor is my x that I'm looking for. Divided by 2 will be equal to that angle, which is 42 degrees. Okay, so obviously we have a couple algebraic paths we can take, but since cross multiplication is what we've been doing a lot of lately, I'm going to take 148 minus x and multiply it by 1. And of course, I get 148 minus x. And then I'm going to multiply 42 times 2, which is going to be 84. Now I'm going to do a little trick. Whenever I have a negative x, I kind of like to bring the x to the other side and change it to a positive. And then I'll just bring this 84 over here. I'll do that all in one step. So I end up with 148 minus 84 is equal to my positive x. And then I'm going to subtract 148 from 84. And I'm going to get 4. I'm going to get 64 is equal to my x. And here the question was, find the measure of arc QS. QS, I did represent it as x, so therefore it's right here, 64 degrees. And yeah, one final question here, number 33. In the accompanying diagram, AD is tangent to the circle at D, and ABC is a secant. All right, well, if AD is a tangent, that means it's going to just hit at that one point. And if this is a secant, it's going to hit at this 2 point, dividing the circle into 3 arcs. Find the measure of angle A. I'll put a little x in there since we've been doing that a lot. If the measure of arc DC is 120, okay, DC is 120. The measure of arc CB is 170. And that's all the information they give us. Well, here you just have to be careful to remember that the 2 arcs that are important in finding an exterior angle with secants and tangents are the minor arc, where they first hurt the circle inside the angle, and of course, where they hit on the outside of the circle. Those are the 2 arcs that we need in order to solve this problem. However, we have that they gave us this 170-degree arc, which is only important in helping us find arc DB before we begin this problem. Because we always should remember that an entire circle will always add up to 360 degrees. So therefore, on the side of my paper, I'm going to take 120, and I'm going to add 170, and that's going to be equal to 290. And then I'm going to subtract 290 from 360, and I'm going to get 70 degrees. So now I can put that 70 in here, and now I have enough information to continue with this problem. It's going to be my major arc minus the minor arc divided by 2 will be equal to that angle. 120 minus 70 is 50 divided by 2 will be equal to that angle, and 25 degrees will be equal to that angle. Here it said find the measure of angle A, so the measure of angle A will be equal to 25 degrees, or I can find my answer right there. And there you have it. I hope you found this video useful, and I'll see you at our next meet.